Assalamualaikum warahmatullahi wabarakatuh. We are SMA 3043 Group 5. In this video, we'll talk about Assignment 1. Here is the group members. One of our members is Wan Nurul Asmimi binti Ramli, Surya Varman anak lelaki Ravindran, Nur Asia binti Aminuddin, Muhammad Iman Arif bin Muhammad Arif. Wan Nurul Asmimi will talk about question 3 and question 6. Surya will explain about question 4 and 7. Nur Asia will explain about question 1 and 2. And Muhammad Iman Arif will talk about question 5. First and foremost, let us take a look on question 1. On question 1 is questions from binomial theorem, which is it needs proof that the positive integer p1 equal to p. In this question, we use a binomial coefficient, which have an equation of nk equal to n pictorial, k pictorial in bracket n minus k pictorial. In this question, n is equal to p and k is equal to 1. And then we substitute the given value in the equation. We can calculate it by using calculator. At the end of the calculation, we'll get the equation equal to the equation given. It is proof that the equation is a positive integer. This question 2. Under binomial theorem, it wants to find 3x minus 4y to the power of 5. In binomial theorem, we have an equation a plus b to the power of n equal to summation of n, k equal to 0, and k, a, n minus k equal to b. Since we are given 3x minus 4y to the power of 5, we should make it equal to the given equation. Then we found out that 3x minus 4y to the power of 5 is equal to the 3x plus negative 4y to the power of 5. In these questions, the value of a is equal to the 3x, b equal to negative 4, n is equal to the 5, which makes the 5 the power of 5, and k is the starting from 0 until 5 since n is equal to 5. We substitute it in the equation of the binomial theorem and we get this equation. After this, we substitute the thing that we get into the L pictorial over K pictorial in bracket n minus K pictorial. And the last answer we get is 243x to the power of 5 minus 1620x to the power of 4y plus 4320x to the power of 3 y square minus 5760x square y to the power of 3 plus 11520x to the power of 2 y to the power of 4 minus 1024y to the power of 5.
Question 3. The followings are about binomial theorem and Pascal's triangle. Question A. How Pascal's triangle relates to binomial theorem? Question B. Give one example for your statement in A and elaborate your answer. Question A. How Pascal's triangle relates to binomial theorem? Binomial theorem explains the way to expand any expression of the form a plus b to the power of n. The greater the power, which is n, of the expression a plus b to the power of n, the harder it is to expand. Therefore, we can use Pascal's triangle to solve any expression of the form a plus b to the power of n. The Pascal's triangle is a triangular array of the binomial coefficient. Each row of Pascal's triangle gives us the binomial coefficient for an expanded binomial of the form a plus b to the power of n, where n in each row of Pascal's triangle. Question B. Give one example for your statement in A. Elaborate your answer. Consider the binomial expression a plus b, supposed to find 1 plus x to the power of n. When n is 0, 1 plus x to the power of 0 equals to 1. When n is 1, 1 plus x to the power of 1 equals to 1 plus x. When n is 2, 1 plus x to the power of 2 equals to 1 plus 2x plus x squared. When n is equal to 3, 1 plus x to the power of 3 equals to 1 plus 3x plus 3x squared plus x cubed. When n is equal to 4, 1 plus x to the power of 4 equals to 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Hence, all these binomial coefficients are generally the element of each row of the Pascal's triangle. For the example, let x equals to 1. 1 plus x to the power of 0 equals to 1. 1 plus x to the power of 1 equals to 2. 1 plus x to the power of 2 equals to 4. 1 plus x to the power of 3 equals to 8. And 1 plus x to the power of 4 equals to 16. And in the Pascal triangle, for each row, the sum of the element is equals to binomial theorem. Questions.
Now, for the question number 4. It states there, prove that A divides B for A, B is the element of Z. So this question requires us to prove that A divides BC. So for this solution, the very first step, we need to let B is equals to AM, as M here we know that it is the element of Z. And C is equals to A times N, which can be said as AN, as N here is the element of Z as well, where we can conclude that BC is equals to A times MN. For the second step, as A divides BC, we can write it as A divides BC, where we can conclude that A, B and C is the element of Z. This does refer to the rules of divisibility. Hence, as a conclusion, we can say that A divides BC is proven and Z here is an integer.
Okay, Assalamualaikum. My name is Muhammad Imam Arif bin Muhammad Arif, and today I'm going to explain to you how to solve the question 5 from the assignment. Okay, the question is, let A, B, C and X be integers with A and B are not both 0 and X not equal to 0. Prove that if GCD A and B equal to 1 and X divided by A, X divided by BC, then X divided by C. So the solution for the question is to show that X divided by C, where C equal to X times K, where K is the element of integers. If GCD A and B equal to 1 and X divided by A, X divided by BC. So let A, B, C, X is the element of the integers, and GCD A and B equal to 1 and X divided by A, X divided by BC. So by the definition of this divisibility, X divided by A, where A times X equal to R, where a equal to x times r, we use this as as the number one equation where r is the element of integers. Next one is x divided by bc, where bc times x equal to m, where b times c equal to sm. We use this as the second equation, where m is the element of integers. So since GCD A and B equal to 1, by considering theorem 4, 1 equal to A times x plus B times y is the third equation, where x, y is the element of the integers. So by multiplying c on both sides of the third equation, we will get c times 1 equal to c times ax plus by, and c equal to c times a times x plus c times b times y is the fourth equation. Okay, the next one is by using substitution. We substitute the first and the second equation into the fourth equation. Then we will get C equal to SR times CX plus SM times Y. And then by using factorization, C equal to X times RCX plus MY. And then we let K equal to, it will be equal to RCX plus MY, where K is the element of integers. And then C equal to X times K, and then by using the definition of divisibility, we will have x divided by c. So this is how we prove it.
6. Using mathematical induction, prove that 9 to the power of n minus 2 to the power of n is divisible by 7 for all integer in n. Let S be a set of positive integer. To prove that 7 divides 9 to the power of n minus 2 to the power of n for n is greater or equal to 1, we need to show, first, 1 is the element of S, and second, n equals to m, that is, 9 to the power of m minus 2 to the power of m is divisible by 7. First, to show 1 is the element of S. For n equals to 1, 7 divides 9 to the power of 1 minus 2 to the power of 1 equals to 7. So, 7 divides 7 is true. Then, 1 is the element of S. Second, to show n equals to m, that is, 9 to the power of m minus 2 to the power of m is divisible by 7. There exists k is the element of integer such that 9 to the power of m minus 2 to the power of m equals to 7k. This is the first expression. For n equals to m plus 1, the expression is 9 to the power of m plus 1 minus 2 to the power of m plus 1. So we separate the index becomes 9 times 9m minus 2 times 2m. 9 times 9m minus 9 times 2m plus 7 times 2m. 9 times 2m plus 7 times 2m is equal to 2 times 2m. So, we have 9 times 9m minus 2m plus 7 times 2m. From expression 1, we have 9 times 7k plus 7 times 2m. Then finally, we have 7 times 9k plus 2m. 7 divides 9 to the power of m plus 1 minus 2 to the power of m plus 1. Then it is true that n equals to m plus 1 if we assume that the statement is true for n equals to m. Also, the statement is true for n equals to 1. Hence, by induction on n, the statement is true for all n is the element of n, that is for all n is the element of n and n is the element of A. Hence, for any positive integer n, 7 divides 9m minus 2n.
Now, for the question number 7, says find all the solution x, y to the following Diophantine equation for which x, y are both positive integer. For the equation x 11x plus 13y is equals to 369. Now, for the very first step, we need to let a is equals to 11, b is equals to 13, and c is equals to 369. As for the very first step, we need to know the GCD of 13 and 11. By using the Euclidean algorithm method, we can write 13 is equals to 11 times 1 plus 2. Then if it does give a proper solution, then we can take this 11 and write it as is equals to 2 times 5 plus 1, where it also does give a proper solution. As 2 times 5 plus 1, we still get 11. So, for the next step, we just write it as 2 is equals to 1 times 2 plus 0, where it also does give a proper solution. So, here, from the very first solution, we know that R1 is equals to 2. And for the second solution, R2 is equals to 1, which this both is not equals to 0, and R3 is equals to 0. Therefore, we can conclude that the GCD of 13 and 11 is 1. Now, for the second step, we can write it as GCD such that C, where we know that from the previous part, GCD is equals to 1 and C is the value of 369, which is 369. So, here we write it as 1 such that 369, where 369 is equals to 1m, and m here does refer to the element of Z, and this does represent the definition of divisibility. Next, we can substitute the value of m here as 369. So 1 times 369, we does get back 369, where 369 here does refer to m, and it also counted as the element of Z. Since 1 such that 369, then this equation has a solution. Next, for the third part, we should find the initial x and initial y as the particular solution, as using the particular solution. Here, to get the value of 1, first we try 11 minus 2 times 5, where we still get 1. Next, 11 minus 13 minus 11 times 1, then times 5, where we still get 1. Next is 11 times 1 plus 5, which is 6, plus 13 times negative 5, where we still get 1. And for the final step, we do calculate it as 11 times 6 and then time 13 minus 5. It does give the same solution as 1, and these both steps are the same. Next, to identify the value of 369. So, for this value 369, we times 1, we still get the original value as 369. So, for this 369 times 1, we can also write it as 369 times 11 times 6 plus 13 times negative 5, where for this part we get 1, and when it times 369, we still get 369 as the final answer. Same goes to the below step. 369 is equals to 11 times 2214 plus 13 times negative minus 1845. We still get 369. Therefore, the initial value of x, which is stand for x0 here, is equals to 2214, and the y initial, which stand for y0, is equals to negative 1845. For the next step, we should find the value of x and y. For finding the value of x, we can write the formula of x is equals to x0 plus b divide d times with t. Here, t, we can say that it is the element of z. As the previous part, we got to know that the x0 here is 2214 plus b here. At the earlier part, we have replaced the value of b is equals to 13, and d here stands for 1 times t. So we will get the equation as 2214 plus 13t to find the value of x. Next, to find the value of y, we can write it as y0 minus a over d times t, where t here is the element of z. From the previous part, we got to know that y0 is negative 1845 and minus a as 11. As the previous part, we have substitute the value of a as 11 and d as the same goes to 1 and times with t. So we will get negative 1845 minus 11t. Next, to find the solution for z to the power of positive, find the solution for x, which is greater than 0, and y, which is greater than 0. Alright, so to find the value of x, which is greater than 0, we can substitute the above equation where we got in the previous part, where 2214 plus 13t is equals to x, where x is greater than 0, then we can replace this equals to x as greater than 0. So here, when we substitute the value of 2214 plus 13t greater than x, and when we solve this, we will get 13t, which is greater than negative 2214. So when we solve this, make t to become the subject, we will get negative 2214 over 13. Next, to find the value of y, we should take the previous equation where we got from the y part is negative 1845 minus 11t is equals to y, where we can write it as negative 1845 minus 11t is greater than 0. So when we solve this, we will get negative 11t greater than 1845, as we took this negative 1845 and shift it to the front. So now to make the t to become the subject, we need to move negative 11 where it does change the symbol, and we will get t is lesser than negative 1845. 1,845 over 11. So after we get the range over here, and we can plot a simple line graph over here. As you can see, I put this negative 2,214 over 13 as the very first point, and negative 1,845 over 11 as the last point. In the middle of this range, I put negative 168 over here. Now, here represent the range where we can say that negative 168 is the element of Z, and T is equals to negative 168. Since we know that the value of T is equals to negative 168, that means the equation 11x plus 13y is equals to 369 has a unique solution, where we can solve the equation as x to find the value of x here, as x is equals to 2,214 plus 13t, where t we substitute the value of negative 168, we will get 2,214 plus 13 times negative 168. As the final answer, we will get 30 as the value of x. For the value of y, we have to substitute the same thing here. Here, we will get negative 1,845 minus 11 times t. T here, as I mentioned, we substitute with the value of negative 168. So we will get 3 as the final answer. So 3 is the value of y. Therefore, the solution x is equals to 30 and y is equals to 3 is corresponding to the value of t, which is negative 168.